Okay, this is our second example, solving using the Gauss-Jordan elimination method. And our system of equations here is 2x minus 6y is equal to 4, and x plus 2y is equal to negative 3. So over in the right-hand corner, we'll go ahead and put our little chart here that follows. We want 1 in row 1, column 1, 0 in row 2, column 1, 1 in row 2, column 2, and a 0 in row 1, column 2. Okay, so first off, we'll go ahead and write our augmented matrix here. So 2 for the x, negative 6 for the y, the vertical line there that can simulate our equal sign, that's equal to 4. And then 1 for the x, 2 for the y, and then this is equal to negative 3. Okay. So first thing we would like to do is we'd like to make a 1 in row 1, column 1. So there's two ways of thinking about doing this. Actually, there's maybe a third way. I'll mention that. First is, we want to divide the 2 by 2. So 2 divided by 2 is going to give us the 1. So if we're going to want to make a 1, we're going to want to divide. Now, more formally, we would say 1/2 row 1, and that's going to replace row 1. Well, multiplying by 1/2 is the same thing as dividing by 2. So if that helps you think about it as division by 2, that'll work also. The third method, we can do a row swap. So we can actually switch rows 1 and 2, and it'll work out. The steps will be a little bit different in terms of, it won't be exactly carbon copy of what we have going on here. It'll be very similar, and we'll still follow this pattern here. Anywho, so we're going to go ahead and divide row 1 by 2. And so row 1 is unaffected. Row 2 is unaffected. So we're going to divide row 1 by 2. So 2 divided by 2 is 1. Negative 6 divided by 2 is negative 3. And 4 divided by 2 is 2. So now we've completed the first step there. Next, we'd like to make a 0 in row 2, column 1. So whatever the number here is in row 2, column 1, that's a 1. So we're going to use the opposite of that, which would be negative 1. Because that's in column 1, this is in column 1, we're going to use row 1. So we're going to multiply row 1 by the opposite of this number here. This number is 1, so we're going to multiply by negative 1, or just negative row 1. We're going to add that to row 2, and that's going to become our new row 2. So we're going to go ahead and draw a little table. You can do this mentally also. So negative row 1 plus row 2 is going to become our new row 2. Okay, so negative 1 times 1 is negative 1. Negative 1 times negative 3 is positive 3. And negative 1 times 2 is negative 2. And that's our negative row 1. We're going to add to that row 2, which is 1, 2, and negative 3. And then we're going to go ahead and add. So we get 0. Negative 1 plus 1 is 0. 3 plus 2 is 5. And negative 2 plus negative 3 is negative 5. Okay, so we did use row 1, but we did not replace row 1. We replaced row 2. So we write our row 1 as row 1, as 1, negative 3, 2. And row 2 is now 0, 5, and negative 5. By the way, once we've performed a row operation, this is our matrix we're going to refer back to. So we don't refer back to the original matrix when I'm talking about row 1 and so forth. Okay, so now we have a 0 in row 2, column 1, so we're halfway there. And the next thing is we want to make a 1. So if we're making 1s, we want to divide. So this number here, where the 5 is, we want to make that a 1. So we're going to divide by whatever number this is. Since it's 5, we're going to divide by 5. Now, dividing by the 5 is the same thing as multiplying by 1/5. So more formally, we would say 1/5 row 2 replaces row 2. Or you can think of it as row 2 divided by 5, and that's going to become our new row 2. So we're going to go ahead and erase this scratch work here. So we're just replacing row 2, so row 1 is going to stay row 1. So row 1 is 1 minus 3 and 2. And 0 divided by 5 is still 0. 5 divided by 5 is 1. And negative 5 divided by 5 will be negative 1. Okay, so now we're 3/4 of the way there. Now we just need to make a 0 in row 1, column 2. Row 1, column 2. Since we're in column 2, we're going to use row 2. And the number there that we would like to make a 0 is negative 3. So we're going to use the opposite sign there, which is positive 3. And because it's in column 2, we're going to use row 2. So we're going to do 3, row 2, We're going to add that to row 1, and that's going to replace row 1. So we'll do our little scratch work here to the side. So 3 row 2 plus row 1 is going to replace row 1. Okay. So 3 times 0 will be 0. 3 times 1 will be 3. And 3 times negative 1 will be negative 3. So I'm just multiplying 3 times row 2. Then we're going to add to that row 1, which is 1, negative 3, and 2. And so we add that. 0 plus 1 is 1. Negative 3 plus 3 is 0. That's the intent here. And then a negative 3 plus 2 is going to be negative 1. So now we did use row 2, but we didn't replace row 2. We replaced row 1. So row 2 is still 0, 1, and minus 1. And row 1 is now 1, 0, and negative 1. Okay. And so you have one extra step. So if you were doing just Gaussian elimination, you would stop here. We're going Gauss-Jordan, so we get to this point here. So we have two equations here. So the first one would be 1x plus 0y. So the 0y is gone. So x is equal to negative 1. And then the second one, we have 0x and then 1y. So just y, and that's going to be equal to negative 1. So our ordered pair is going to be negative 1, negative 1. What I'm going to go ahead and do is I'm going to plug in negative 1 for the x and the y in both equations here of my system of equations. Make sure that that checks out. So 2 times negative 1 minus 6 times negative 1 is going to be equal to negative 2. And then we got negative 6 times negative 1. So think of a double negative there. So that's going to become positive 6. So negative 2 plus 6 is 4. And so that's what the right-hand side of the equation was there, so that looks good. And we'll check in the second equation. So x was negative 1 plus 2 times y, which is negative 1. So that's going to give us negative 1 plus negative 2, and so that's going to add up to negative 3. So that checks out also. And so our solution is going to be the ordered pair, negative 1, negative 1. Okay? All right, that's it for this example, and we'll see you next time.